Hello and welcome to this section of the Chemistry Tutor. In this sequence of lessons, we're going to start to talk about the topic of redox reactions. And we'll talk about what that means in just a minute. But the bottom line is it's a class of reactions that are very, very important in chemistry. And it's also a class of reactions that gives students a lot of problems. And that's because when you start dealing with redox reactions, it's a little tough at the beginning before you know the process, how to balance those reactions. And so even if you followed up to this point in chemistry well, a lot of students might look at redox reactions and redox topics and then get confused and cumbersome or feel like they're being cumbersome in solving their problems. Well, what we're going to do in this section of the course, in this sequence of lessons, is we're going to start at the beginning of redox reactions. We're going to talk about a lot of basic topics, basic definitions that you really need to comprehend and understand up here before you can really solve any problems. So we're going to cover that. Then we're going to work tons of problems of different types, walking you through easy ones and kind of inching your way along. So if it feels like we're going a little slow, it's because everything I'm teaching you really and truly is essential stuff. I'm not trying to teach you stuff that's not essential. So make sure that every time we learn a skill, that you can really and truly understand it and work those types of problems yourself before you move on. And then you'll be successful. Okay, so let's take a quick recap of where we've been on our journey of chemistry. All right, so we've learned about elements, we've learned about compounds, we've learned about how things join together and form up, we've learned about ionic and covalent compounds, and so in the course of that, in the previous parts of the Chemistry Tutor, we've learned a lot about chemical reactions, right, how things combine. And then we've also learned about the concept of stoichiometry, which just means you're using that chemical reaction that you've written down in order to calculate things, how much of something is formed. How many milliliters of a solution do you need to react with this? So we've used the reaction, the chemical reaction, with the coefficients out in front to do the stoichiometry problems. And then we worked a long time on acid-base reactions, which is a huge class of reactions because acids and bases are all around us. And in the course of the acid-base reactions, we talked about lots of different topics. One topic I want to take a minute to kind of pull out for you here is the topic of the net ionic equation, or ionic equations that we were talking about when we did those acid-base reactions. So if you haven't reviewed any of this previous material that I'm talking about, please take a moment and go back and review it. Make sure it's fresh in your mind, because chemistry, much like a math class, it's building, the topics are building on one another. So we're going to learn things in this section that are going to apply to these types of problems here. So what we need to do is make sure you have those skills in place before we move on to the next topic. And then if you do that, you're actually saving yourself a lot of time, okay? And the thing I want to point out and just make sure you understand is the topic of net ionic equations in particular in the previous sections of the class, in those sections. Please make sure and go back specifically to that and make sure you remember what a net ionic equation is, because it is very, very important, and it's very much going to be used in all of these redox reactions, or a lot of these redox reactions. So it's better if you just have it in the front of your mind. All right, so let's go ahead and write that down. Make sure you're just comfortable with what we're studying here. Redox. So it's a word that's not really in the dictionary, but the reason that we use it is because it's descriptive. So RED means reduction, and ox means oxidation. All right, so basically, oxidation is something you've probably heard of before. Most people have heard of the term oxidation. Most people before chemistry probably haven't heard of the term reduction. But it turns out that the process of oxidation, which we're going to talk about in a minute, and the process of reduction, they really go hand in hand. You really cannot have oxidation without also having reduction. So they always happen together, and I'm going to say that a ton of times because it's very important. So we have this class of reaction that involves oxidations, and so because they always involve oxidations, they involve reductions. They go hand in hand. We put those two words together and we call it redox, because I guess oxred doesn't really sound too, doesn't roll off the tongue, so we call it redox. That's what we're talking about here. So the easiest way to talk about redox reaction, let me just give you a brief overview, and then I'll give you a quick example, and then we'll go through the general idea. The whole process of this particular section is, what is oxidation and reduction? I want you to come away with this section knowing what that means, and then we'll go on to the next sections and really dive into it a little bit more. Okay, oxidation and reduction is basically a class of chemical reactions where not only are you concerned with balancing the reaction as far as the elements, okay, that's what we've always been doing so far, but oxidation reduction is a class of reactions where we have to worry about the charge that's transferred inside the reaction. So in other words, we're mixing two things together and we have some products forming. In a redox reaction, electrons are actually transferred. They come off of one item in the reaction, they float around for a second, and then something else absorbs them and kind of takes them in. So we have the oxidation part and we have the reduction part. I'll give you definitions in just a minute, but the bottom line is you need to think of oxidation and reduction as gaining and losing electrons, right? The process of gaining and losing electrons is the process of this redox, this oxidation and reduction. We'll give you definitions in a minute, but because the electrons are being transferred, then that means that charges are kind of moving around. These types of reactions can be difficult to balance if you don't have a specific process. So as we go through this course, I want you to really have it in your mind, okay, that the main point of what we're doing is to get your skills so that you can balance redox reactions. That's really what we're building to. We have a lot of topics to get there, but I want to get you to the point where you can balance these reactions. So that's basically what we're doing. So I said that redox reactions involves, two things reacting, but also a transfer of charge going on in there. So let me explain with an example exactly what I mean by a transfer of charge to kind of illustrate that point. Okay, so let me draw a little line there. Let's combine two things together. Let's combine the following two things. Magnesium, which is a solid metal in the periodic table, and oxygen, which, at least at atmospheric pressure and temperature, is a gas. So we have magnesium, which is a solid metal, and oxygen is a liquid, is a gas, actually, obviously. Okay. So what happens when you put these things together? That's the question. Well, let's figure it out. If I put magnesium and I go ahead and combine it with oxygen, basically I'm going to burn this magnesium is what happens, all right? Then you need to kind of try to predict what's going to happen. So let's go ahead and try to see what might form. So we have magnesium and we have oxygen. Now if you go and look at the periodic table, when we first looked at combining things to form compounds, we learned how to predict what it would look like. Magnesium, when you go look at the periodic table, is in column number 2. That means that it's really going to have a +2 charge. Actually, let me go ahead and just be consistent here, and I'll tell you why in a little bit. I'm going to write it as 2+. Usually when you're writing the charges, you put the plus sign or the minus sign after the number. And oxygen, if you go and look, it's kind of in that second column from the end, from the noble gases. So oxygen really likes to have a -2 charge, right? So when you take magnesium and you put it together with oxygen, the magnesium likes to have a charge of +2, the oxygen likes to have a charge of -2. We've learned this, almost in the first lessons of chemistry. Okay, so the way you figure out the subscripts is you go and crisscross like this. So this 2 is going to come down here, this 2 is going to come down here. Now, basically what we're saying is if you combine these things, it likes to combine in the ratio of 2 magnesiums to 2 oxygens, the ratio of 2 to 2. And we've already talked about when we learned about writing compounds that basically we can reduce this to magnesium oxide, MgO, because a ratio of 2 to 2 is the same as a ratio of 1 to 1, right? So all I've done so far is stuff that we've done in one of the first lessons that we had in our sequence in chemistry a long, long time ago, many hours ago. And that is, if we take magnesium and we combine it with oxygen, magnesium likes to have a +2 charge. That comes from the periodic table. Oxygen likes to have a -2 charge. That also comes from the periodic table. When you combine them, the ratio is 2 to 2, which is 1 to 1. So when we write that reaction, we really are going to say that magnesium oxide, MgO, is what likes to form. So the reaction that's actually going to happen here is going to be magnesium, which is a solid, plus oxygen, which is a gas, and that's going to yield MgO, which is a solid, okay, which is a solid. So this is unbalanced. This is not a balanced reaction yet, but what we're saying is this plus this is going to end up giving us this. So now what we really have is a skeleton reaction. We know that magnesium is going to combine with oxygen. It's going to give us MgO. And if we wanted to balance this reaction, we would just look at atoms, right? So we have 2 oxygens here. So we're going to need 2 oxygens here. And because we put a 2 here, now we have 2 magnesium. So we come over here and we put 2 magnesiums. And so we balance this reaction. Okay, everything's balanced. Now this is a pretty simple reaction to balance. Okay, because it's fairly simple. This is actually a redox reaction, and I'm going to show you why it's a redox reaction in just a second. But I wanted to let you know that the types of reactions that we're doing in this section, you've probably already seen some redox reactions from other sections in chemistry. We've already talked about lots of reactions that happen to be redox. They just happen to be simpler. So a lot of redox reactions like this one, they're not too big of a deal to balance. But what we're going to find out later on as we get into this is that a lot of these other types of reactions that are a little bit more complicated, especially reactions that are like net ionic equations and we have to balance them, those can be challenging if you don't know the proper methods. So this is a redox reaction. And since we said redox reactions involve electrons being gained and lost, then something in here has got to be donating electrons and something has got to be accepting electrons. Right? That's what the definition here. And I haven't written a definition of oxidation and reduction down yet. We're getting to that point. But the point is, or the idea is, the product of this reaction is MgO. So let's take a look at this. I'm going to write it really large, GO, magnesium oxide. The reason I'm going to write it very large is because basically magnesium, as we already said up here, I'm just rewriting this, it likes to have a charge of +2 and oxygen likes to have a charge of -2. So if you notice, the magnesium is combining into this compound over here, and in the process, see, this is a neutral atom. See, when you have a magnesium as an element like this and oxygen as an element, these are neutral atoms. These don't really have any charge because atoms are neutral. But in the process of combining into this thing over here, it actually loses electrons. Because you need to think about how the atom is structured, right? You have the positive nucleus, which are all positive protons in there, and neutrons, which are neutral, but you have the positive charge in the middle, and you have this cloud of electrons out there that are all negative. Okay? So the only way possible that this magnesium can end up from being a neutral 0 to a +2 charge, the only way that can happen by electrons being gained or lost is by this guy to actually lose electrons. That's the only way that can happen. So what happens here is the magnesium loses electrons. And how many electrons does it lose? It has to lose 2 electrons. That's the only way that that can happen. This is a neutral atom, 0 charge. So it goes from a charge of 0 to a charge of positive. Protons in the nucleus do not, they do not leave the nucleus like that, okay? So the number of protons in the nucleus tells you what element it is, okay? So the number of protons might tell us that we have magnesium on our hands. Those electrons on the edge, those can kind of come and go in the process of chemical reactions. And this is telling us that this magnesium loses 2 electrons in order to do this. All right? Now this guy, this oxygen, by contrast, it gains 2 electrons. It gains 2 electrons. The reason we know that is because we started this reaction with neutral oxygen atoms. Well, in this case, they're bound together in molecules, into molecules tied together, but still, it's a charge of 0. Everything's neutral. Somehow, when we form this guy, oxygen is having a charge of -2 when it's bound up like this, okay? So that means that somehow 2 electrons have gone in and kind of attached themselves over to this oxygen. That's the only way I can have more of a negative charge. So the magnesium actually loses 2 electrons and the oxygen actually gains 2 electrons. So what does that mean? If I had to kind of draw a picture from the magnesium, right, over to the oxygen, I would draw an arrow like this and I would say, this is the electron transfer. In other words, somehow this magnesium atom loses 2 electrons, they float around for a second, and then the oxygen sucks them in, and isn't that so convenient? The oxygen loves to suck in 2 electrons, the magnesium loves to donate 2 electrons, so that's what happens. Okay, and that's what happens in that redox reaction. Now, the reason that it's called redox is because there's electron transfer going on inside this reaction. Electrons are coming off of something, and then I say that they're floating around, but really it's instantaneous. Electrons are coming off of something and immediately sucked into something else. That electron transfer in the process of a chemical reaction means that we call it a redox reaction. It means that we have oxidation going on, and it means we have reduction going on. So now that you have a concrete example in your mind of how electrons can be transferred, okay, and basically from one species to another, now let's go and define the topic or the concepts of oxidation and reduction so that you can have a good solidified definition in your head. This is so crucial, okay? So for definitions, we have the term oxidation. So I have danced around it a lot so far because I don't like opening a section and dumping a definition on you. But now that we've done this, I can dump this definition on you. Oxidation is when a substance loses, and I'm going to say electrons, but the way you kind of abbreviate electrons in chemistry is with an E and then like a negative sign up there. You need to get used to seeing this. You're going to see that a lot in chemistry books. E with a negative sign. You're going to see it all the time. This means, in general, the word electron. All right? And so that is the process of oxidation. Now let me go ahead and change colors a little bit, and then I will say reduction. The process of reduction, what do you think it's going to be? If oxidation is when a substance loses electrons, forget about what the word looks like it will mean. Reduction is when a substance gains electrons. All right, now you need to stare at this for a second because it's incredibly important. In fact, the entire topic of this whole sequence of lessons is all about oxidation and reduction, which we call redox reactions. So it's really kind of important that you understand what oxidation and reduction is, all right? A lot of times, you know, we'll talk about something being oxidized. We take a piece of metal, we put it out in the yard, and it might be oxidized. We might take, you know, iron, okay, and throw it out in the yard, and it might oxidize and form rust. But we throw these terms around in general, general conversation. But what do they mean? What does that actually mean in terms of chemistry? And in chemistry, we have a very fundamental definition. Oxidation, the term that you're familiar with, you know, in terms of everyday life. Oxidation is when a substance loses electrons. You need to burn that in your head. Burn it in right now. Say it to yourself. Oxidation, I'm losing electrons. Oxidation, I'm losing electrons. Oxidation is when I am the atom and I'm losing electrons. That is the concept of oxidation. Reduction is very confusing to students because reduction, you would probably think something's having reduction, that it's losing electrons, but it's not. Reduction is the opposite of oxidation. It's when a substance gains electrons. So it's like an opposite thing going on here. If something is reduced or if it's having reduction, it's actually gaining electrons. So if I'm an atom and I see a nice electron over there that I want to snatch up and hang on to, and I go and grab it and it sticks in my electron cloud, so to speak, then I've undergone reduction because I've gained electrons. Now, I don't know how it's better for you to internalize this, but everyone needs to look at these definitions and memorize them, because if you get kind of careless and start thinking that reduction is like losing electrons, then you're just going to get yourself in trouble. So think about it for a second. Oxidation, the thing that I know about that happens to metal when I put it out in the yard, oxidation is when I lose electrons. Oxidation is when I lose electrons, and reduction is the opposite of that. It's when I gain electrons, okay? Another definition I'll give you that can confuse students, but we're going to set that straight here, is the term oxidizing agent. Okay, let's talk about what an oxidizing agent is. It's the substance that accepts the electrons. And when I say it accepts the electrons, what I mean is, in a redox reaction, something's being oxidized and something's being reduced. They go hand in hand. If something is losing electrons, something must be also gaining those electrons that have been lost. So oxidation and reduction are tied at the hip. That's why we call it redox, okay? So in a reaction, if something is being oxidized, it means it's losing electrons, okay? Then there must be something present in the reaction that's taking those electrons in, that's accepting them. We already talked about that. Whatever that is in there that's taking those electrons in, that's called the oxidizing agent. I kind of think I know why they use the term oxidizing agent, but I almost like to rearrange that term and call it the agent of oxidation. It's the thing that makes oxidation possible. So the oxidizing agent is whatever is in that chemical reaction that is promoting the oxidation, allowing it to happen, and the way that happens is it's accepting these electrons that have been donated. All right, now I can round it out by giving you the final definition, which is the reduction or the reducing agent. Okay, so what do you think that means given our definition before? The reducing agent is going to be the substance that helps reduction along in the reaction. So it's the substance that donates the electrons. All right, so basically, like we said before, we have reduction. So reduction is when something gains electrons. The reducing agent helps that process along, and the way that it helps the process along is it's the thing that donates the electrons in the first place, so that the thing that's being reduced can accept them or gain them, okay? So these things are kind of, they go hand in hand. When you identify a reaction, the first thing you want to do is figure out what's being oxidized and what's being reduced, what's undergoing reduction. Oxidation is when things lose electrons. Reduction is when things gain electrons. So in every chemical reaction, every time you have oxidation, there's going to be a corresponding oxidizing agent that's helping it along. So in the case of oxidation, when a substance is losing electrons, the oxidizing agent is the thing that's taking those electrons in. It's promoting that oxidation, okay? Reduction is when a substance is gaining these electrons, so there has to be something in the reaction that's helping that process along. And in this case, if the thing that's being reduced is gaining electrons, there has to be something in there that's donating or liberating those electrons to begin with, so that the thing that's being reduced can actually gain them. All right, so that's enough talking about words. You know, what we're going to do is write a reaction, and I'll show you a lot of times on your test what you'll be asked to do is identify what's being reduced, identify what's being oxidized, and then tell me what's the oxidizing agent, tell me what's the reducing agent in this chemical reaction. So it's very, very common, and that's what we're going to do right now. Let's go back to our reaction that we have had some experience with. So what we just talked about is 2 magnesiums plus O2. So we're burning magnesium metal. Believe it or not, you can burn it. 2 MgO, okay, and it turns out that that's a solid. If you actually take magnesium metal and you put it under a very hot torch, it will burn very bright, like so bright that you can't even look at it. And then it forms this kind of white powder. That's the product, magnesium oxide. All right, so now that we have learned so much already. Remember we talked about over here, we said the magnesium, it likes to go from 0 charge to positive, so it has to lose electrons. Okay, so what we've learned from before is that this guy loses electrons. Okay, so because it loses electrons, we say that the magnesium is oxidized. The magnesium is oxidized. And we also talked before that the oxygen goes from a charge of 0, neutral, and it takes on a negative charge, so it has to gain electrons. So based on our definition, when a substance gains electrons, we say this is reduced. So let me go ahead and just say the oxygen is reduced. So all we've done so far is use our definitions up here. So we know from looking at the charges over here that this guy, over in the end, it wants to have a positive charge, so it has to lose electrons. So we say it's oxidized because that is what happens. We'll call a substance that loses electrons. This oxygen goes from 0 and it wants to be a negative charge over here, so it must have gained electrons. When things gain electrons, we say it undergoes reduction, or we say that that thing has been reduced. Okay, so that is what's going on here. All right, now that we've identified in the reaction what is being oxidized and what is being reduced, let's see if we can figure out what is the oxidizing agent and what is the reducing agent. All right, and the way that you look at this is you try to figure out, you can use your definitions, that's fine, but really the shortcut is if you know what's oxidized, so then you can then say that magnesium automatically, it's the reducing agent. And since you know that this oxygen's been reduced, you can say that this is now the oxidizing agent. So the bottom line is, because these things are all interrelated, if you identify what's being oxidized, then the agent is just the opposite agent. So since this is oxidized, we know immediately it's the reducing agent. Since this is reduced, we know immediately it's the oxidizing agent, so that you can just use the opposite term when talking about the agents. But now we can go into the definition and make sure it makes sense. The oxidizing agent is a substance that accepts the electrons in the reaction. Okay, the oxidizing agent. So we're claiming that this is the oxidizing agent, and in fact we do believe that the oxygen is the thing that's taking in these electrons because it wants to be negative charge in the end. Okay, and then we say that this is the reducing agent. Okay, we say that this is the reducing agent because magnesium is the substance that is donating these electrons to begin with. So you see how it looks complicated at first because there's something being oxidized, and then there's something being reduced, and then there's an oxidizing agent, and then there's a reducing agent. But honestly, once you know what's oxidized and reduced, you automatically know what the oxidizing agent and what the reducing agent is, because it's just going to be the opposite, term that you're looking at. So once you identify what's being oxidized, you automatically know it's the reducing agent. Once you know what is being reduced, you automatically know what's the oxidizing agent. So make sure you understand these terms. These are not hard terms. The definitions are plain English. They're not really long, but you do need to stare at it a little bit, and that's why I wanted to give you this concrete reaction that you can visualize. Everybody can look at magnesium and realize that it wants to be positive. Everybody can, because we've used the periodic table enough up to this point. All right, so magnesium wants to be positive. That means it must have lost electrons. If it lost electrons, then it has to be oxidized. All right. Oxygen wants to grab those extra electrons because it wants to be negative, so we know from the definition it has to be reduced. Once we know what's oxidized and reduced, the opposite term is what tells us the agents, because that's just how the definitions are constructed. So what is the reducing agent is magnesium, because the reducing agent is what's donating the electrons and they're jumping off the magnesium. And then what is the oxidizing agent? That is the thing that is accepting these electrons in the reaction, and that's why we're doing this guy right here. So if you really wanted to be explicit, during this chemical reaction, really, I could draw an arrow to here, and I could say this is the electron transfer. Okay, so the electrons are jumping off of magnesium atoms and they're landing on these guys, and when they do that, they're combining and they're forming magnesium oxide, but the electrons are coming and they're flowing one direction. Something is donating these electrons, which is the magnesium. Something is accepting these electrons, which is the oxygen. So if you notice back, when we first opened this section up, I told you one of the very first things, redox reactions are reactions involving the transfer of electrons, or the transfer of charge is what I think I said, right? And now you can see it explicitly. And I also told you that oxidation and reduction always go hand in hand. You can never have oxidation without reduction also taking place. You can never have reduction without oxidation also taking place. They're always joined at the hip. You have to remember that. And now, hopefully, without just a boring definition, I'm showing you why that's the case. If something's donating electrons, something must be accepting and taking those electrons in. So I'm going to close this section out with one final little mini example, but I want to drill a few things in. I think I've said a lot of these things. Oxidation and reduction always happen at the same time. We've talked about that. Redox reactions involve oxidation and reduction. That's what redox means, which means transfer of electrons. And now that you know the definitions, you can predict what's being oxidized and what's being reduced in the reaction. The final thing is, redox reactions are very common. A lot of the chemical reactions in your body are redox reactions. Lots of chemical reactions in nature, very common reactions, like rust and things like that are redox reactions. So they're all over the place. And it turns out that when you have redox reactions, especially if they're happening in a solution, and then things can get even a little bit more complicated, not in terms of the oxidation and reduction, but in terms of balancing the equations. They can get more complicated than this. So we're going to learn a process of balancing redox reactions to help you with that. So I want to give you one more quick example, since this is a good introduction to oxidation and reduction. What if I had the following reaction? Let's say I had copper ions that we already had as +2, and these are in aqueous solution. So I put something in a solution and I end up with some copper ions that have a charge of +2. And then to that I add zinc, which is a solid. And let's just say that out of that reaction I end up with copper as a solid neutral atom, and then I end up with zinc in aqueous solution as an ion. So this is kind of an example of one of these ionic equations, these net ionic equations that I was talking about. If you also remember, I said net ionic equations. Go back and review them. I think I mentioned that to you. And this is the reason why, because this is a net ionic equation. You know, you really don't go to the shelf off of the store and buy copper ions and just dump them into a solution. You really don't. Everything's bound into a compound, all right? But a lot of compounds dissociate in water and they break down into their ions. We talked about dissociation in a previous lesson in our chemistry tutor, right? So when you see something like copper ions like this that are in aqueous solution, what it means is I've already dumped something in a solution like copper sulfate or something like that, that dissociates down, and I have these copper ions that are left in solution. And to that I add zinc. Now somehow some electrons are transferred here, and the copper, which was an ion, it ends up being a neutral atom now. And the zinc, which was neutral to begin with, ends up being an ion in the solution. So you notice that if you just look at balancing this reaction, you have one zinc atom and you have one zinc atom, and you have one copper atom and you have one copper atom. So this is balanced in terms of atoms, okay? But still, there's electrons being transferred. Electrons being transferred. So we know that there's oxidation going on, we know there's reduction going on. So how can we figure out from looking at this what's being oxidized and what is being reduced? Okay, so let's see if we can figure that out. Well, we look at the copper, and we know it has a charge of +2, all right? So copper has a charge of +2, but on the other side of the equal sign, there is no charge here. So somehow we had a positive ion go from having a positive charge going to 0. So the only way that can happen, is in the process of this reaction, this guy has to gain electrons. That means gains electrons. It has to, because if I have a plus charge, then I need to put some electrons on there to make the atom neutral again, right? So you can look at these ions that have a plus charge. You know, normally atoms have equal number of protons as electrons, okay? So when you have a plus charge on an ion, it means it's lost some electrons. Some electrons have already gone away somewhere, and I'm left with a net positive charge from the nucleus. So the only way to go from that positive charge to a 0 charge is if it takes some electrons in to make it neutral again, okay? So in this case, it's gained electrons. So because it's gained electrons, what do you think is going to happen? Oxidation or reduction? When something gains electrons, we say that it's reduced. Or we say that it's undergone reduction. Make sure that you're comfortable with that. When something gains electrons, we say it's reduction or reduced. Okay, so that's all we've done there. Now, what do you think happens here? Well, this zinc is already neutral, and somehow it loses some electrons because now it's got a positive charge. So it's a neutral atom. The only way it can be positive over here is that some of the electrons have gone off and kind of floated away, so to speak. So this loses electrons. And what do we call it when something loses electrons? When something loses electrons, we call it oxidation. Make sure you're comfortable with that. When something loses electrons, we call it oxidation. So all I've done so far is I've looked at this reaction and I've used logic. That's all I've done. I've said the copper was positive, it became neutral, so it had to have gained some electrons. So we say it's been reduced or undergone reduction. The zinc, it lost electrons. It's the only way it can be positive over there, so it must have undergone oxidation. Notice that I told you before, oxidation and reduction always happen in pairs. They always happen together. That's what we have. Something has been reduced, something has been oxidized. Okay, so we should be able to always identify the same thing. Now, what do you think is the oxidizing agent and what's the reducing agent? Well, the way you can do that easily without referring to a definition, once you know what's being oxidized and reduced, the agents are just the opposite. So this is the oxidizing agent. And because this is oxidized, I just picked the opposite. This is the reducing agent. Okay, that is the quick way that you do it. Once you identify what's being oxidized and reduced, the agents are just the opposite, okay? But if you wanted to use terms, definitions, the oxidizing agent is the substance that accepts the electrons. Substance that accepts the electrons. This must accept electrons in order to be neutral, okay? And the reducing agent is the substance that donates the electrons in this reaction, okay? So this donates the electrons because this was neutral to begin with and it became positive. It must have been the thing that donated the electrons. So that's why, because these are interrelated definitions, once you know what's being reduced, you automatically know that it's the oxidizing agent. Once you know what's been oxidized, you automatically know it's the reducing agent. So I've tried to give you the definition so you understand logically, and I've tried to give you some hints on how to actually look at a reaction and identify that. So if I wanted to be explicit, I'll just draw one more thing and we'll close this section out. The big picture is I have copper in aqueous solution, and I'm adding to it zinc, which is a solid, and I get copper, which is a solid, plus zinc, and it's a charge of +2 in aqueous solution. All right, so now that we know what's been oxidized and what's been reduced and what's gaining electrons and so on, from the copper to this copper, if you go over here and like draw like an arrow like that, this gains 2 electrons, okay? So we say it's reduced. And that's what we already said. We already said that the copper's been reduced. I'm just writing it again in terms of the chemical reaction so you can see it. And the zinc, from here to here, we say that it loses 2 electrons. And because it loses 2 electrons, we call it oxidation. What's going on here in terms of writing it down and seeing it as a chemical reaction is going from this species, we have to gain 2 electrons in the process of this reaction. In this species, we have to lose 2 electrons in the process of this reaction. So you have a gain of 2 electrons and you have a loss of 2 electrons. Notice that everything's balanced in terms of electron gain and loss. The zinc happens to lose 2 electrons, and the copper happens to gain 2 electrons. Now, isn't that convenient that one of these guys wants to lose 2 electrons, and one of these electrons wants to gain, one of these species wants to gain 2 electrons. So because you have this nice thing where one thing wants to lose the same number of electrons that the other thing wants to gain, that means this reaction likes to happen. That means it will happen, okay? And so that's one way that you can look at the details in the electron transfer to figure out what's going to happen in a redox reaction. So in a redox reaction, the bottom line summary, okay, is that we have electrons being gained and electrons being lost. The electrons gained and lost are balanced, so we lose X number of electrons. We have to be gaining X number of electrons somewhere. And another way of saying that you might see in your book is that charge is conserved in a redox reaction. Charge is conserved. When you see something that says charge is conserved, it just means the electrons gained has to balance the electrons lost. All right? So that wraps up this section. It's a very important section. It's a great introductory section, and we've gone from 0 to great understanding in a short period of time. We've talked about what is the concept of redox? What is the concept of oxidation in terms of definition? Oxidation is when you lose electrons. What is reduction? Reduction is when you gain electrons, okay? Those things go hand in hand. We've also talked about the oxidizing agent and the reducing agent. We've done a couple of quick examples to show you how that would happen. So the thing I just want to point out to you is that you've probably already seen redox reactions up to this point, but we just didn't point out all the electron transfer because it can bog you down early on. But now you're to a point where you should understand reactions. You should understand basic stoichiometry. Now we're going to start to unwrap that present and start looking at how the electrons are moving around, and that's going to help us learn how to balance these reactions when they get a little more complicated. So follow me on to the next section. Take it one lesson at a time. Make sure you understand every single lesson before you go on to the next one. And then I think you'll find that redox reactions, while it might seem difficult at first, is really something that everyone can conquer and everyone can comprehend.